Hey everybody, I'm Steph Clark, and I wanted to do a review of how to find the equation for the tangent plane of a given function. So first thing I like to do is write out the tangent plane equation just so I know where to start. And so that equation is z equals f of xy plus the x partial times x minus x1 plus the y partial times y minus y1. And I always start there because we're going to use the given function and given points of the problem to find the components of this equation. So that's important to make sure everything stays organized and you can know where you are in the process. So looking at web work number 9, problem number 1, the given equation is z equals f of xy, which is equal to e to the y power plus x to the third plus 7. And then the given point is 2, 0, 18. So first things first, we're going to find the partial derivatives of the function. So the x partial, y is going to be considered a constant. So all it's going to be is 1 plus 3x squared. And then the y partial, x is going to be a constant, so that one's pretty easy. It's just going to be e to the y power. So then the next step, looking back at our tangent plane equation, we're going to find the values of those derivatives at the given point. So first is going to be f of 2, 0 is equal to e to the 0 plus 2 to the third plus 7, which is equal to 18. And then x partial at 2, 0 is equal to 1 plus 3 times 2 squared, which is equal to 13. And then the y partial is y partial at 2, 0 is equal to e to 0, which just equals to 1. And then now that we have those, we can just plug those into the tangent plane equation and get our answer. But you also want to remember that Professor Seeberger wants us to write the equation out using this notation, but with the given point. So make sure you get full credit. That's important. He mentioned that a couple times in the lecture videos. So just make sure you do that. And that actually gives us the answer to the first part of the question. So it's going to be z equals f of 2, 0 plus the x partial at 2, 0 times x minus 2 plus the y partial at 2, 0 times y minus 0. So that's the first answer in that question, and you want to make sure every time you write it out that way first. It's just important, you just got to do it. And then plugging in our values, it's going to be 18 plus 13 times x minus 2 plus 1 times y minus 0. Break it down further, it's going to be 18 plus 13x minus 26 plus y. And then our final equation, which is the answer to B, the second part, is going to be 13x plus y minus 8. And so that's the tangent plane equation. And then it also asks us to approximate the value at the point 2.13, negative 0.04. So you're just going to plug those values into the tangent plane equation to get the answer to C. So it's going to be 13 times 2.13 plus negative 0.04 minus 8. And it's going to be roughly 19.65 as the approximation at that point. And what you can always do is to check that your tangent plane is actually the tangent plane. You can use the CalcPlot program to check it. And so I entered my values in here. So function 1 is the original function and function 2 is the tangent plane equation. And in the actual graph, you can see the original function there, and then the tangent plane right here. and the red dot is the point 2018, and so you can see there that the tangent plane is actually tangent to the function, and it checks out. So I hope this helped a little bit, and if you have any questions, let me know. Thanks.